Teams, NVIDIA and Intel have been working in a secret on jointly developed processors for a year. The Trump administration has no involved in this partnership at all, targeting hundreds of millions of the client PCs. The Intel and NVIDIA have been working on the jointly development processors for client and data center project for about 1 year. Now, as both companies see huge opportunities behind their Intel x86 RTX SoCs and custom NVIDIA x86 data centers processors. Although the NVIDIA CEO Jensen Huang said in a press call that the Trump administration was pleased with the collaboration between the two leading U.S. companies, it had nothing to do with it. Trump not involved. The Trump administration had no involvement in this partnership at all, said NVIDIA's Huang said during the joint press conference with NVIDIA on Thursday. They would have been very supportive, of course. Today I had the opportunity to tell Secretary of Commerce Howard Lutnick and he was very excited and very supportive of seeing two American technology companies working together. The work began around a year, and a preliminary agreement was reached by the Intel CEO Pat Gelsinger and NVIDIA's Jensen Huang even before that. A year ago, Joe Biden was president, though no one suggested his administration was involved either. Intel and NVIDIA are working on a custom data center CPUs, and NVIDIA will integrate its AI platforms as well as GPU styles. Intel will integrate it into each upcoming client processors. In both cases, CPUs and GPUs will use NVIDIA's NVLink technology as an I/O interface. By now, there are 3 teams working together on the joint project. The working is ongoing. The NVIDIA says, the Intel Intelligence, the NVIDIA says. 2 technology teams have been discussing and architecting solutions now for probably coming out to a year, and Jensen Huang, chief executive of the NVIDIA. The architecture teams, the 3 architecture teams are working across the CPU architecture as well as the product line for sovereign PCs. The architectural work is fairly extensive, and the teams are really excited about the new architecture. The teams have been working for a while, and we are excited about the announcement today. As Huang mentioned, the team working on a CPU architecture as well as client and data center product line. We figured out that NVIDIA wanted rather deep customization of the Intel's genes to meet the needs of its AI platforms. The involvement of the CPU architecture team highlighted the depth of the partnership between Intel and NVIDIA as well as indicate that the CPU company is implementing less than deep optimization required by the next generation AI platforms. Given NVIDIA's history with the Grace and Vero CPU custom ARM and the high bandwidth needs of the next gen GPUs, and for example Rubin, Feynman, and opposed to Feynman, and etc. It's original to expect a tailed cache structure, memory, I/O, and the coherence protocols for these x86 CPUs. Such a deep collaboration probably means that a custom Intel processor will be used by NVIDIA sometimes in the post-Vera Rubin platform era. You'd certainly expect NVIDIA's data center GPU team to work with Intel as well, but Huang never mentioned one during the call, probably because the Feynman GPUs haven't already been defined by now. Yet he mentioned that there are 2 more teams working on a product line for server and PC product, which probably joined to a data center system level architecture team on the NVIDIA side as well as a client CPU system level architecture team on Intel side. While the collaboration between the Intel and NVIDIA on the data center front is multifaceted, across the organization effort. The timing to each fruition is tied to of the emergence of the Intel's custom CPUs for NVIDIA. And for the joint work on the client project or project, developing an Intel CPU with the NVIDIA GPU chiplet will take at least 3 to 4 years from a drawing board to volume production. The collaboration requires deep integration across SoC fabric dimensions, performance, power consumption target, packaging technology for various EMIB and software stacks from both companies. The collaboration likely began in 2024, so the first product could hit the market in late 2027 or early 2028. Hundreds of millions of PCs. While we do not know for sure whether Intel and NVIDIA plan to come up with a jointly developed product, it looks like that they intend to address a broad range of applications. At least Jensen Huang said that the two companies plan to build CPUs that could address the vast majority of notebooks, which point to hundreds of millions of devices. Just notebook market is 150 million notebooks sold each year, said Huang. So that kind of gives you a sense of the scale of the work that we are going to do here. We are going to address the consumer market. We are going to address the vast majority of the consumer PC market and consumer PC notebook market. Following the okay. Next one is both companies introduced the industry-first chiplet-based NPU samples, expanding supply to global automotive OEMs. Eagle offers a flexible scalability from the 250 to 2,000 more TOPs, achieving a 5 times higher cost efficiency than existing automotive SoC with applicability extending to robotics. Korea sold September 4th, 2025. Both Semiconductor BOS today announced a major milestone with the successful delivery of fully functional Eagle N NPU AI accelerator sample to multiple leading global automotive OEM customers. Eagle N is the industry first chiplet-based 250 TOPs dense NPU for the automotive sector, combining cutting-edge chiplet architecture with the string safety standard required for vehicle applications. The Eagle N, the engineering board. Following initial evaluation conducted by an OEM customer, Eagle N has received highly positive feedback, particularly highlighting its strong performance and complexity as to support a wide spectrum of AI models, from vision applications CNN-based to language and multi-modal applications transformer-based. Separately, benchmarking results demonstrated up to 5 times better performance per dollar efficiency for region 500% better token generation efficiency on Llama 3.2 1 billion compared to existing automotive SoCs. This milestone lays of the foundation for a smooth transition into mass production in near future. The Eagle N 250 TOPs NPU powered by Tenstorrent Gen 10.6 technology is designed for advanced driver assistance system ADAS, automated driving AD, and vehicle infotainment IVI and platform. Leveraging a chiplet-based architecture, Eagle N scale up to 2,000 more TOPs and addressing the compute demands of the future autonomous and connected vehicles. So in its first engineering sample release, Eagle N demonstrated flawless operation across the range of the AI models, covering everything from the CNN-based vision to transformer LLMs and multimodal foundation models. So the achieved flawless performance on our first pass silicon is exceptional a milestone in highly integrated and high-performance semiconductor, underscoring both engineering excellence, said Jae-Hong Park, CEO of both semiconductors. We are expanding our collaboration not only with the global OEMs, but also Tier 1 suppliers, robotic innovators, and edge computing leaders, positioning Eagle N for a smooth transition into mass production next year. Thanks to strengthening both our strategic partners engaged in the developed automotive solutions for our global OEM and Tier 1 customers, said Aniket Saha, VP Product Strategy at Tenstorrent. Both Eagle and powered by the Tenstorrent Tensec MPU, designed for maximum scalability, is set to transform the automotive SoC landscape. About both semiconductors. Both Semiconductors is an automotive fabless company led by Dr. Jae-Hong Park, a former executive vice president of the Samsung Semiconductor System LSI and foundry business. Headquarters in South Korea, there are regional offices in Vietnam and Germany. Both is specialized to develop AI and MPU-focused advanced ADAS and IVI SoCs and subsystems to bring more valuable and alternative solutions into automotive industry. More information can be found at bothsemi.com. So the next one is NVIDIA and Kioxia target 100 million IOPS SSD in 2027. AI server drives aim to deliver 33 times more performance. Who is HBF? The Kioxia is working with NVIDIA to build a solid-state drive that would deliver 100 million random IOPs already in 2027. The company said at a news conference earlier this month, Nikkei reports. NVIDIA reported plans to a new couple of such SSDs is totaling a whopping 200 million IOPs attached directly to each GPU and to boost the AI performance. We will proceed with development in accordance with the proposal and request from NVIDIA, said Koichi Fukuda, Chief Technology Officer of the Kioxia SSD division. 100 million IOPS SSD. Kioxia's drives with 100 million random read speeds are projected to use a PCIe 7.0 interface to connect to GPUs in a peer-to-peer mode and will be exclusively designed for use in AI servers that need to process a vast amount of data quickly. Today's high-end solid-state drives can deliver around 3 million 4K random IOPS and about to meet the performance needs of modern and upcoming GPUs, which optimizes for burst memory access. They need to get substantially faster and changing the way they interact with NAND media. Earlier this year, Silicon Motion's CEO Wallace Kou told Times Hardware that NVIDIA was interested in building SSD that offer as many as 100 million random IOPS, 33 times more than existing drives can deliver. Around the same time, Kioxia disclosed plans to build a XL flash-based AI SSD set with over 10 million 512 kilo random read IOPS in second half of 2026. AI workloads rely on a frequent small random loaded to retrieve the embedding model parameters or database entries. In such cases, 512-byte blocks better represent the actual usage patterns than 4-kilobyte blocks and provide lower latency, while drives operated 512-byte blocks may not be delivered the same low bandwidth as typical SSDs with 4 kilo blocks. It is easier to scale out sequential read or write speeds with multiple drives than to lower than the latency of conventional SSDs. It remains to be seen whether Kioxia's AI SSDs with 10 billion 512 kilo IOPS random performance will materialize in 2026 after Kioxia plans to build drives with 100 billion IOPS random performance in 2027. Using Excel Flash, what is interesting is how exactly the Kioxia plans to build each 100 million IOPS drive. Each proposed AI SSD is based on Excel Flash, which is Excel's NAND memory with high endurance, very low latency, and very high performance. Kioxia's Excel Flash devices feature 16 planes, up significantly from 3 to 6 planes on modern 3D NAND devices for client PCs, which point to a higher sequential and random performance, as Kioxia does not publish specifications of Excel Flash. It's impossible to judge the per-device performance of this memory type. Meanwhile, considering that InnoGrit Tacoma-based 400GB Excel Flash SSD with 32 NAND dies, with 7 allocated with over-provisioning and PCIe 5.0 X3, X4 interface delivered 3.5 million random read IOPS and 0.5 million random write IOPS. So we can estimate that each die contributes up to 109,375 random read IOPS and 15,625 random write IOPS, though this calculation comes with some caveats. Assuming perfect linear scaling across loads of NAND devices, 100 million 512 byte IOPS SSD would require 915 of such dies, presuming the same levels of over-provisioning. Now that Kioxia knows how to pack 32 NAND ICs into a single package, it can certainly build a drive based on 915 Excel flashes ICs in 28 packages. Such a drive would require a special controller with at least PCIe 5.0 X16 host interface, though PCIe 7.0 4x4 would be more preferable. The problem is there is no perfect linear scaling. Real-world performance of NAND devices and SSDs is limited by channel bandwidth, multiplane constraint, command pipelining of RAID queue path, queue depth, and firmware, and loads of other factors. Hence, the test case scenario for 100 million 512 byte IOPS SSD features Excel Flash devices is a multi-controller module with dozens of the control and switch. Such a solution may well make sense in all flash arrays, but Kioxia is explicitly talking about an SSD. Welcome, HBF. Since understanding traditional 3D NAND memory for 100 million IOPS SSDs to 512 byte blocks is not exactly feasible, whereas using a brand new type of media of a commercial data center grade product is highly unlikely, Kioxia might instead look to emerging technologies that use NAND memory in an unconventional way. One of such technologies is probably high bandwidth flash HBF that packs up to 16 NAND devices and logic die, a controller, into a single stack and interconnected them using TSVs and microbumps, while HBF layers will still use proven NAND memory cells. They are organized in multiple arrays to achieve a very high level of parallelism and therefore performance. We do not know whether the Kioxia plans to use HBF for the project or stick to something similar. However, it's safe to assume that the knowledge it will gain from the experimentation with the HBF to build ultra-high performance SSDs is something the company intends to leverage. Deca and the Silicon Storage Technology agreed to develop NVM chiplet solutions. Deca Technologies Silicon Storage Technology (SST), a subsidiary of Microchip, have entered into a strategic agreement to develop comprehensive non-volatile memory NVM chiplet package to help customers with the adoption of modular multi-die systems. Agreement to develop the NVM solutions created. The announcement comes as traditional monolithic chip designs are growing in complexity and cost, and this collaboration will look to combine the Deca's M-series fan-out and adaptive patterning technology with the SST's Super Flash embedded flash technology. Both companies are set to apply their system-level integration expertise to deliver a bundled offering that will help customers to design, verify, and commercialize NVM chiplets. By providing greater architectural flexibility, they are aiming to offer both technical and commercial advantages over traditional monolithic integration. The collaborative solution will offer a modular, memory-centric foundation for advanced multi-die architectures. The chiplet package leverages SST's Super Flash technology, along with the interface logic and physical design elements required to function as a self-constrained chiplet. This is then paired with adaptive patterning-based Lie distribution layer RDL design rules, design flow, simulation flows, test strategies, and manufacturing paths provided by a Deca's ecosystem of qualified partners. Building on this foundation, Deca and the SST will jointly support customers from early design through qualification and prototype manufacturing. The companies said that by streamlining integration and accelerating design cycles, they aim to enable bolder adoption of heterogeneous integration, engaging with the customers globally to bring chiplet of solution to market. Chiplet integration is reshaping how the industry thinks about performance, scalability, and time to market, said Robin Davis, VP of Strategic Engagement and Applications at Deca. Our partnership with SST empowers customers to develop a chiplet solution that combines different chips and process nodes and sizes and even die from the multiple foundries, delivering a more efficient and cost-effective product. So the chiplet technology has significant advantages as a way for designers to go beyond the traditional scaling to deliver enhanced functionality and performance. Chiplet allows the reuse of existing IPs and can facilitate the mixing of advanced process nodes with less expensive legacy geometries, and by utilizing the most appropriate die technology for particular function. Chiplet can offer a more versatile, efficient, and economical pathway in terms of advanced semiconductor innovation. As our customers push the boundaries of the Moore's law, they are expressing great intersection in chiplet-based solutions at Market Titan, the Vice President of Microchip's licensing business unit. This partnership aims to deliver a comprehensive package of IP, simulation tools, and advanced assembly and engineering services necessary for successful chiplet development and productization. Okay, next one is leading UK semiconductor firm up for sale. A leading UK semiconductor firm has put itself up for sale and is in a negotiation with a buyer. IQE in Wales makes wafer substrate for companies to build compound semiconductor lasers, photonics chips, and gallium trade GaN chips for RF and power applications. Compound semiconductors are key area for UK semiconductor strategy, and the loss of IQE would be a significant blow to the strategy. This comes as the RISC-V core and tool developer Codaship in Germany is also up for sale, marking the potential loss of another sovereign European technology supplier. However, IQE is facing a cash crunch at negotiations with several companies for the sale of its operation in Taiwan, and the proceeds would be used to repay its revolving credit facility and provide cash to investment in its core operations. IQE has had a troubled few years with its chief executive Americo Lemos stepping down suddenly in October last year. IQE CEO in shock departure. The company is expected to make a loss in the first half of this year on a turnover of £44 million, $50 million. The full year revenue is expected to be around £100 million and $120 million, down from the $118 million in 2024. This would put the price at around $120 million. The loss comes from the further of certain contracts in the wireless and the photonic segment as a result of continued global and macro uncertainty. This slowed down the unbinding of the inventory levels at customers built up in 2023 and 2024, as well as lower spending in the U.S. military and defense sector, said Jutta Meyer, recently confirmed as Chief Executive Officer. There are a number of potential semiconductor firms could be a buyer for IQE, and the company is in talks with one of them. Soitec in France manufactures and engineers silicon wafers, and the IQE product line would be complementary. European chip maker STMicroelectronics is moving into photonics and already has a strong product ranges using semiconductor wafers and GaN chips and flavors vertical integration from water to device. However, it recently saw its first loss and is in a process of acquiring the MEMS business of NXP for $950 million. IQE is also working with the Belgian foundry X-FAB on a 1,200 V GaN part, but the X-FAB is likely to remain a customer rather than a buyer. Outside of Europe, Korea and the US is leading a substrate supplier, including photonic, and has no GaN business, but it's been closing and selling off wafer plants. Thank you for your time. See you next time.